criteria associated with that have to, in total, make the product really differentiated in the marketplace, so the customer, or so the vendor, has the motivation to want to go out and sell that as an upsell, potentially, compared to other products in their product line. And labeling can be effective. For a lot of products, it really depends on how the product is bought and sold. A lot of products these days are bought online, or you walk into a retail store. Having visibility there of the label is an important attribute. Not all products are that way, but at the same time, the communication of the information behind the label is important and can be meaningful to customers. Sometimes the label, the Energystar label, is really just the tip of the iceberg there. Yeah.
You're probably going to get to this, but what is your policy for refreshing your standards over time?
Yeah, it's a good question. We'd like to refresh them as much as necessary. And so what that might mean is we try to measure market penetration of Energystar each year in a particular market category. So we do a market assessment every year for every one of our products to try to judge the market penetration as it approaches, depending how fast the market moves. Some areas are very mature and move very slow. We've got some products that are not dynamic, like IT. If Energystar grows by 5% in a couple of years, that may be significant. CFLs are a perfect example. It took us a long time to get out of single digits for CFLs and for lighting fixtures. And so we have to make a decision 20, 30, 40, 50%. When we reach some number, we open up the process again to do a revision. Increasingly what we're doing, and I think this makes more sense with IT products because they do change quite frequently, is we'd like to try to do a multi-year plan with targets called tiers that put in place a good roadmap for manufacturers. So, because clearly some manufacturers would like to leapfrog, or they at least, if they don't want to leapfrog, they at least want to know what's coming down the path 2 or 3, 4 years down the road. So we have a lot of flexibility there. Sometimes we only do a tier because we just don't know what the market's going to be like in a couple of years. We don't know where we could potentially be. So we design all these specifications to fit what the market currently is. This is just a description of sort of the process we use. Kind of hard to read, I understand. Let me just basically say that it generally sort of starts in a relatively innocuous way when we decide to do a new product category. It used to be the case that there were so many products we could look at. It was easy to say, all right, let's do this product, and then we'll do this product. There's probably something there. Let's just get started and go for it. But I think that we've sort of run out of a lot of good categories of products to look at. There aren't that many more that are low fruit on the tree, so to speak. So I think we have to be a little bit more thoughtful. We also now have so many specifications that the care and feeding and nurturing of those specifications consumes the majority of our budget. We just can't go off and do new specifications because it does take time and effort to be able to do those. Organizations like SNIA are really valuable because, frankly, they can help bring to bear a lot of thought, technology, and interest, and help us get to speed rather quickly. So this process really, we do some sort of analysis and say, gosh, it looks interesting. Let's talk to people. Let's see if there's something there. The process inevitably gets more technical. We have meetings, not surprisingly. We release a draft. We're about to do that with servers. That helps to get the conversations going with industry. We have a process probably not unlike, frankly, how industry does standards. It is interspersed with a lot of international coordination with my counterparts, and I think that's a very valuable thing. You are living and working in a global environment. Your products are globally traded. We want Energystar to be globally applicable. So by working with us, we can to some degree, hopefully deliver a specification that will also be used by other governments as they deploy Energystar in their own markets.
Questions?
Yes?
So in the previous chart, you mentioned multiple options for to achieve such efficiency is necessary, right? Then also that differentiation is one of the key, right? And when we think about approach, bottom up or or top down, when we think about refrigerator or some consumer electronics, this product has such a Energystar label, right? Then building was also, right? So variated from the green Energystar green viewpoint. But when we think about the building, it's a kind of such a small component that just piled up, right? So such building has a huge number of refrigerators.
Mm-hmm.
So power of such kind of building is just summation of such kind of small component power consumption. So how we just, some kind of, when we just piled up such small thing, eventually, sometimes total number of power supply, power consumption might be beyond some. So how can I make a kind of trade-off?
I'm not certain I'm getting that. Maybe I don't know. I don't know if anybody else wants to take a shot at phrasing that. Are you saying that in any building there are lots of individual things which use energy?
Yeah, that has an energy. Excuse me, Energystar label.
Mm-hmm.
And whole building also is just variated from a green energy viewpoint.
So how do you, what is the relationship between the products and the
Even though such building that's using Energystar product, all the product components are that kind of Energystar label. But the building itself, it variated from a green viewpoint. But I'm not sure that such building just still under the threshold or something. After the.
I don't know that I've ever gotten that question. I don't know.
I think it's the building versus the components in the building.
Right.
And the performance.
Well, I think what we're trying to get at with building metrics, and we're trying to do this with data centers, is that the operation and maintenance of the buildings, separate from the products that are in them, are meaningful. And that's probably even more the case with your typical office building. Probably for a data center, actually, the products actually in the building, the storage, the servers, the UPSs, the PDUs, et cetera, probably do have a really, obviously they have a really substantial impact on the energy consumed, but they really just sort of change the profile. Yeah.
I would think probably most of the vendors in this room would like for the UPSs and all that stuff to be considered part of the
and
it's part of the power delivery system.
Sure. Yeah, when we think of IT, we think of just, we're not thinking PDUs, UPSs, or anything that delivers power or converts it. We're thinking only of server storage, et cetera. And conceptually, you want to use as little power in any, if you looked at any data center, if you took the IT power versus what the total power of the building is, you want what is not being used for IT to be as small as possible. And your ability to do what you want to do with as little power as possible is ideal. So I don't know if it's to your point at all.
Well,
Yeah.
if I understand this question accurately, but maybe what it's asking is, if the subcomponents each are supposedly efficient, does that guarantee that the whole large unit is efficient?
Yeah, that's my point.
No, it does not.
And maybe there's some cases where actually maybe you want to have one of those components inefficient so that you make overall efficient.
It's very possible. Yes.
Is that kind of what you were getting at?
Yeah, that's
Yes.
the point, yes.
Yes.
If I just buy, no, the energy storage product in the building, then eventually I just certify that, my building is certified.
Right,
energy
right.
storage.
Well, another example would be Energystar homes. Energystar homes have nothing to do with products. It's all about the building envelope. And so a different point would be, we accept that in a complex building environment, someone may choose to have something. There are going to be trade-offs sometimes. And sometimes you may want a more inefficient something. And technology by itself doesn't necessarily solve your problems, as we know, because there's been lots of new technologies introduced into commercial and industrial building environments, and the building stock has not really gotten that much more efficient. So a lot of it really is operation and maintenance. So, Esther, you have a question?
Yeah, are you going to talk about the federal rulemaking process? Specifically, are there opportunities for non-SNIA members to, if we were basically drafting a specification here, you talk about non-SNIA members being able to have an opportunity to comment and object if necessary or augment?
Yeah, well, maybe this slide sort of gets to that a little bit. As the federal government, we have to give everyone a say who wants to participate. And when we write Energystar specifications, we are actually not asking for a consensus opinion from the industry. It would be to the public's disadvantage for that to be the way we develop specifications. What we want to do is, in a perfect world, we'd ask every manufacturer individually what they thought. And frankly, we have to give individual manufacturers or individual stakeholders the opportunity to speak to us publicly, privately, whatever they want to do. But there is a lot of value in working with trade associations specifically for this, for that reason, to bring everybody together. So we'd like to try to sort of have our cake here too. So.
It's not a regulatory rulemaking, though.
Right.
It's I don't know technically what it is in the bureaucracy,
it's
but
a hybrid.
Yeah, it's not. It
Yeah.
doesn't have to be signed off by OMB or it's. Energystar is much more flexible than,
Yeah.
for instance, the Department of Energy.
That's what I was looking for. So you don't go through like the NOPR and all that?
Yeah, there's
Yeah,
not that
yeah, that's a
process.
very, referring to DOE's processes, that federal efficiency standard, that's a very regimented process which unfolds over many years generally. Tends not to be the sort of thing that would be very good for the IT sector, given that you guys
We don't move that slow?
evolve, a dozen times over by the time they actually got the specification or got the standard finished. So this is just to say, really quick, when we're working with people, working with industry, working with other stakeholders, we try to consistently deal the same way with everyone. We try to have a transparent process. We try to be responsive and customer service oriented. I think that that's important. And we try to be clear going forward about what our goals and objectives are, and what the opinions that have been shared with us, so that everybody sort of gets the benefit of that. So we talked about this. This sort of gets to that point. National Labs, EPA, UE, we have a variety of consultants. Lots of different folks involved. This is probably not at all comprehensive, but gives you a snapshot. So let's talk about the things that we've done in the IT sector. We've done specifications for computers, monitors, imaging. We probably will build on that, I hope. This is the computer specification that just went into effect July of '07, and I think we now have how many models? A couple hundred?
700.
Oh, 700. Excuse me, 722 qualified models. So that's pretty good uptake, and that's pretty rapid. In a couple of years, we're probably going to need to revise that specification. In fact, what is already going on is the Tier 2, which hopefully will take effect sometime next year, I think. Is that right?
July.
Yes. Ours is Sorry, I work on way too many products to know specifically what everybody's doing. But there's some key criteria for the computer specification. We've really been sort of enamored to some degree at the benefits of power supply efficiency, that is the efficient conversion of power, in this case from AC to DC. If you do that, well then no matter how you use the product, it's going to be more efficient than a product that has a less efficient power supply. So that hardware specification ensures that we can get real, true savings, and I think that that's a benefit. Previously, our specification was really just focused on, did someone have the power management settings enabled, which we all know is user-dependent in terms of what those savings are. So we worked with a company called Ecos Consulting, one of our actually subcontractors. They went to utilities and said, would you be willing to help, would you be willing to pay incentives to power supply manufacturers and to vendors to help drive the sale of more efficient power supplies and desktops? And that was enough of a trigger to help move things, and then Energystar was able to come along and specify those more efficient power supplies. So we're actually thinking about doing the same thing with servers. Maybe potentially it could be a criteria for other products. This is really hard to read. Let me just explain it really quickly. There were no power supplies, or virtually no power supplies, that had really flat efficiency curves, and yet there were some, and we created 80 Plus to try to stimulate the marketplace. And if you go back to February of 2007, once there was a clear indication that Energystar was going to include it in the specification, there was about we got up to about 130 different power supply SKUs or models, excuse me, from a whole variety of different manufacturers here. And now we're up to about 200, I think. So that's been a real good success. We've really helped to sort of transform what was really sort of a commodity market to some degree and help them move towards greater efficiency where it wasn't commonplace before.
So you mentioned a lot of different SKUs. How many different manufacturers are represented?
Well, back in 2000 or early 2007, I think there's about 20, and now they've got 200. So I think it's probably not many more than 25 manufacturers, maybe, because there's not that many, frankly.
Do they have that sort of similar distribution to what you see in storage business or many other IT industries? 80% of the business.
Yeah,
is
no,
five.
actually we don't yet. We don't. We're hoping to replicate the success we had. Excuse me, to replicate the success we had at desktops with some of these other product areas. So that was the point there. Imaging equipment, I won't dwell on this much. We've got a test procedure, for example, that might be interesting to some of you. For the longest time, Energystar for imaging equipment was how much energy is it consuming when it's not doing its job, when it's sitting there for long periods of time. We felt like that was inadequate as products were changing, usage patterns were changing. So we really developed a test procedure to say Energystar is, one, how efficient are you when your product is sitting there for overnight for 10, 12 hours, but also how efficient is it when it does a standard job. And so we created basically a workload to measure the energy consumed by this standard job. And we now apply that to the products. It took a couple years to write. It was really pretty difficult, but it's established and and I think it has a better capability of withstanding changes in the marketplace as opposed to just simply focused on a modal approach.
So just on that one, for example, clearly in sort of the top half is about energy consumption, the bottom half is about power utilization.
Yes.
And do you have any sense of where you're going with other IT equipment, whether you're more interested in energy or power?
It's a good question. I mean, I think that, I don't know, I think they're both important and both necessary to be explored, but I couldn't say 100% standing right here, right now, that it's going to be either or. I just don't know. I wish I could be more specific, but I think only through conversations with people about the benefits and opportunities, and frankly, talking with more customers to see about what's valuable to them.
One of the factors there, for example, if you're more concerned about power, that has a big effect on sizing of cracks and PDUs. just on, and, you know, what you can do to do the instantaneous cooling when you have to. If you had a nice flat even energy load, which we generally don't, depending on the workload that we have,
Right.
that's a different environment.
Right.
Also, the tariffs, since what in the end case the customers are generally concerned about, many of the large data centers are getting charged on a 90% of their peak rate, and the energy charge is almost immaterial. Right? If you look at at a big data center like Google,
Right.
they're paying at whatever their 90% peak is, and that's the charge that they pay. And whether they have peaks and valleys and troughs in between those is almost irrelevant.
Right. Well, and you may have something to say about this as well, but I mean, that's where actually the incentive to reduce peak power would actually be, the utilities are often very interested in that. And of course,
Sure.
as you probably know out in the Northwest, you know, probably a lot of that hydro was underpriced. And it's now, we're now probably experiencing long-term resource deficiencies, or at least an investment from a utility perspective. You know, Puget Sound Energy, if you believe their long-term forecast, they think they needed to make $4 billion in infrastructure to add new supply. They actually now think it's actually more like $14 billion because all the renewables we had seem to be disappearing faster than we thought. And so that's the long-term resource issue is one thing. And then, of course, we don't really have the problem in the Northwest like other parts of the country do, where everybody flips on their air conditioners for 3-4 months a year, and they really would like to reduce peak. So, so depending on your pricing, it may be an incentive for you to reduce your peak, but certainly the utilities, not all of them, but some of them, enough of them, I think, across the U.S. are starting to realize that data centers are, if they're willing to pay,
Right, they'll pay for peak shaving.
yeah,
Yeah.
then I would say, yeah, take some of that money back.
We talked about that yesterday, or a couple days ago with Fred Moore.
Sure, exactly.
Well,
Yeah.
one thing,
I'm sorry, go ahead.
Before you get off this, the one thing I'd add is, if you go back to the program goals, the climate change goals, that's energy. So, you know,
Yeah.
so energy ultimately is the currency that Energystar is trying to achieve.
Fair enough.
And in that particular case with the imaging equipment, the two different test procedures are used in different product categories. So the larger copiers, multifunction products, those get the annual, the total energy consumption, which, because their usage pattern is more relevant. The operating mode, where you're just measuring power in different modes, are used for smaller products like inkjets, which tend to sit idle much of the time. So
Well-
it makes more sense. You know, the test procedures are adjusted according to the market and the operating
Right.
conditions and those sorts
I
of
think it's fair to say we don't have a one-size-fits-all.
Yeah.
That's-
Okay, I mean, to your point on that the climate issues are directly related to energy consumption, not necessarily, because when you're peak loading, you're very often using some pretty inefficient units, either thermally inefficient or real high-priced fuel sources. So I don't think you can carry that argument as far as that you might want. As a first-order approximation, sure, that's good.
Yeah, it depends on the part of the country, but yeah, so energy tends, you know, that's the goal, is saving energy.
SW, I would add too that within some of the product categories, you also see it sort of shifting with time, as opposed to what we have here with the printers, with
Yeah.
two different characteristics. Computers, for example, the tier 1 that's in effect now looks at active idle power as
Okay.
one of the requirements for power savings, and then in tier 2, they're looking at some more advanced metrics that might be do something more like the TEC approach there with printers. So that's the case where, you know, the power, looking at just straight power, is sort of an intermediate step before trying to maybe look at overall energy.
Okay,
Okay.
thanks.
Oh, yeah, I'm sorry, go ahead.
So one of the things that the technical workers are struggling with is trying to figure out, you know, what are typical load patterns? Do you have guidelines for that? How do you decide?
Typical load patterns for an entire data center or for?
Well, no, in this case, it'd be for a storage array, but you had, on the previous slide, something about typical
Typical energy consumption,
energy
yeah.
consumption patterns and so.
Right, well, we created one that was typical.
How did you decide it was typical?
Well, we sat around and argued about it.
That's-
So, well, you know, but I mean, it's somebody might say, well, my multifunctional device makes, 50,000 copies a year, and the same device in a low utilized environment may use 5,000. But when they're actually making that one copy, I mean, that's, it's just the same thing 50,000 times over. So we were able to come up with a usage pattern. I think people were able to agree upon it. That is a reasonable approximation of real world energy consumption. So.
But to bring up computers again, which is just one of the areas I work in, so that's why I probably keep bringing it up. But they've actually, in the Tier 2 development, have some software that I think some of the stakeholders developed that different companies have volunteered to try out and actually installing them on desktops and notebooks, and they're actually data logging, over a series, I think, 30 days, how often is this on, how often is it off, how often is it. Right, so in that case, it's very active going out and getting actual user data to try and see if they can come up with it.
It's just your same techniques that you wonder about.
Back there?
Unfortunately, one of the problems that I think Alan was sort of alluding to is the fact that not only do we have many workloads that we have to deal with in our storage arrays, but typically there are many workloads simultaneously with the same storage array. For the most part, I mean, most of our products have perhaps some unique features or aspects that if we were to pick any one workload would favor that particular product over another when we're trying to compete for more even big. So I'm not sure what the answer is, and yes, but
Right.
Alan and I will start
Well,
battling it out with others.
we'll get to the bottom of that, because I can guarantee you that almost that comment verbatim has been said in every industry meeting that we've ever been in.
We're especially. I find that hard to believe.
Yeah. So consider yourself part of the pack. So on the issue, moving on to servers, I think get into the meat here. Clearly, servers and maybe to some degree storage more in the future is driving the need for all of the infrastructure to help keep it cool. So we thought, let's look at that. And also, we had a lot of established industry relationships. It made sense for us to look at servers to see whether or not Energystar was something that might work for this particular type of product. So again, we want to create a protocol because one doesn't exist to measure server energy efficiency to ensure a level playing field and drive competition. Clearly, a lot of manufacturers make energy claims, but can consumers fairly compare them to one another? Hard to say. And not all customers are created equal. Some have a more sophisticated approach to how they buy things and the analysis they do. Others don't. It could be that there are enough volume servers sold to small and medium-sized businesses that Energystar could be very valuable to that environment. To some of the, obviously to the guys at Google, I mean, this is not going to be of use to them. So, at least I don't think so right now, maybe in the future. A couple key things. We need to develop definitions. What products are we talking about? They need to be very well articulated. What categories? What defines those? Are there physical or functional characteristics that they have? What are the test procedures that we need to measure or use to measure what energy is consumed? What is its energy efficiency? We need to look at that. Once you get this information about energy consumption, energy efficiency, how do you, what specifications, what are the, how do you rank products in order to draw a line or draw multiple lines to determine who's Energystar, who's not? And then, clearly, it's very, very important when you design these specifications that you give people a clear articulation to the best of our ability of where things will be going in the future. Best example I ever have of this is we spent a couple of years initially working on these copier specifications. I guess I'm talking about IT-related stuff because it's an IT audience, but we worked with Xerox and all these other companies, and then the specification came out, and Xerox said, oh, by the way, we're not going to qualify any products. We wanted to have, be part of the conversation, but we're not going to qualify anything. we're going to design our stuff so that we're 2 or 3 years ahead, and we're going to tell everybody about it because we want our competition to invest in this to keep up with us. So we had set it tier 2. They knew what the levels were, and they were like, "That's what we're shooting for." But they didn't tell anyone until we were done, which I thought was kind of brilliant. So. So anyway, so different companies have different ways of doing things. Yeah. Oh. Oh, data centers. Yeah. I thought about that today. I was playing. I thought no one will think of that. So, all right. So why cover servers? I think many of you probably know more about this, or hopefully these are fairly obvious. There might be any number of reasons. This could probably be this is not anywhere close to being exhaustive of list. I mean, why cover servers? I have my reasons. Customers that buy these things by the hundreds or thousands may have theirs. Manufacturers that sell them to them may have their own motivations. So this is just a snapshot. Why focus on power supplies? That oftentimes is not entirely obvious. Again, we think we can get some guaranteed savings, common hardware denominator. It does follow on a precedent that we developed already, and it's many of the same manufacturers in the power supply space. And we think we've got the technical elements of it under control, and we think we have a real good team at the Electric Power Research Institute, who initially started all this with the California Energy Commission. So moving on, just real quick. Oh wait, I'm sorry, Arthur, you were going to cover these slides.
Yeah, I can cover the next couple if you want.
Yeah, why don't you jump up here and do that real quick.
So again, I'm Arthur Howard with ICF International, and I end up doing a lot of the technical research and analysis for some of these different specifications in the IT space. So as I was mentioning before, I did a lot of work on the last computer specification, and now I'm supporting Andrew as we look at servers and storage. So the next couple slides are just going to go through some of the criteria we're looking at for the server specification, and we're currently working on writing a draft that will be out in the coming weeks. So these are kind of the finalized criteria we're going to put out for comment in our draft 1 specification, which will probably still have a lot of placeholders and a lot of questions where we're trying to fill in gaps in our knowledge. But this is sort of the current and up-to-date thinking. So the first graph here is just a graph of a lot of different power supplies that have been tested as the 80+ program, which we used for the computer specification, which was 80% efficiency at 20, 50, and 100% of load. They're also working on a server specification, and this is some of the data that we've gotten from them. So one of the things that we're looking for there is a relatively flat efficiency curve. So for the 80+ program, the big thing was that it was 80% at 20, 50, and 100% load. So you have to meet all 3 of those targets in order to qualify that power supply, meaning if your computer is running in anywhere in that range, then you're getting 80% efficiency. Because the typical, this would be an example of sort of an older power supply that isn't going for a broader range of efficiency, because it drops off really quickly as you get past sort of 60%. So what this chart is really meant to show is just the range of efficiency values that you get at the different spots in the load curve. Yes?
So if I had a product that had multiple power supplies in it, the Energystar rating wouldn't be as a result of the overall behavior of the system. It would be based on whether each of the individual power supplies could meet.
Right, so this is basically based off a lab bench test, where you're testing just the efficiency of the power supply at these different load curves. But to get to your point of redundancy in power supplies, what we're looking at for the server specification, which makes it a little bit different, is that we're actually advocating for a 10% load criteria instead of just 20, 50, and 100, because the idea is if you have 2 power supplies in these things and they're splitting the load, you're going to get a lot of servers, maybe when they're at idle or not doing a whole lot, that are going to be down that 10 to 20% range, because they're never going to get above 50%, and they're probably never going to hit 50% in the first one.
Following that, I think the question was not necessarily done in parallel power supplies, but maybe a power system where you have a series of serial. You have a mains converter and distribution with multiple down converters distributed up to the system.
Okay.
How does this apply?
You're
was
talking
actually
about a
both.
system
Yeah.
outside of the server?
Sorry, no, inside the server.
Oh, inside the server.
You might come into the mains and have say an unconverted to say 400 volt DC, and distribute that throughout the cab, and then have multiple down converters throughout the entire environment for a larger system. Whereas a smaller one will just use one monolithic brick with
Right. Yeah, and that's one of the challenges we're facing. Sorry if I misunderstood your question.
Well, I meant both, so.
Oh, okay. But that's one of the challenges we're facing, is looking at, what we've heard termed end-to-end efficiency, right? So from where the energy comes into the server to where it's actually delivered to the chip and all the different equipment that's in there. So right now we're initially looking at power supplies, and that might be a way, just that initial power conversion, because that's what we did with desktops. There are certain people looking into board DC to DC efficiencies. I think it's a really tricky issue when it comes to testing and everything, but the general idea here is if you're saving power, at least even in just this initial step, then that's a step in the right direction, and there'll be sort of guaranteed savings there.
This also gets to the product classes, because initially the spec is just for volume servers, right? So these are the 1U, 2U, 3U type servers, not the mid-range or mainframe type cabinet servers. So, I think there are two principles there. One is it's important to divide it into the right product classes, and the other is that it's an incremental process. Initially you kind of fire off the ones that are easiest to address and hopefully the most energy use or most common, and then you, over time, address more of the market as you can. So this is addressed at a particular slice of the market, particular design.
Right, yeah, and as this indicates at the top, this is really just for single voltage. So single voltage power supplies at 230 volts, which is sort of our understanding of what you would have in a typical volume server, or small to mid-range servers.
Due to inactivity in your conference, this call will be terminated unless you press the digit 1 on your telephone. 1.
Spin down. And there's an example of why spin down is not always a good thing.
Okay, so this slide just has a couple observations of what we were just looking at. And the first is just showing that there is a spectrum of efficiencies in there. You're seeing a lot of different lines at different levels, different curves. So there is an opportunity to differentiate within those power supplies which is more efficient than other, which is really what our job is. As sort of pointed out, the efficiency drops off rapidly right now, below 20%. That's one of the reasons we want to look at this 10% load condition, because when you have a lot of servers running there, then we have to make sure that the power supplies are meeting a target in that range. Another point here is, and this is just sort of to differentiate between the desktop power supply criteria, which is based on multi-voltage, that's the 80-80-80. Single voltage tends to have higher efficiency. One of the points there is the lack of DC to DC converters to do all your different multiple outputs. You're just usually getting the one output, which would be the 12 volts. And also a lot of servers are operating at the 230 volt level, where you tend to get more efficiency. So any other questions on power supplies before I move on? Okay. So there are a couple other criteria we're looking at. Some of these are, again, based on some of the work we did with the computer specification specifically idle power, which is one thing we're looking at. So we've seen some research that a lot of these servers are sitting idle a lot of the time, similar to how desktops and notebooks might sit idle a lot of the time. So that's one of the things we're looking at. We're doing a lot of work with the Spec Power subcommittee of the Spec organization, which I saw as one of the groups you identified as looking to work with in the future. So they have just released their first workload for their power and energy benchmark back in December, and that includes measurements of idle power and maximum power. So that's one thing we're looking at as a possible testing element to look at idle power. Now, whether we're going to have criteria based on idle power, which could be a complicated thing, but we're definitely looking into, or whether that might just be a sort of reporting requirement for information for the end user, remains to be seen. But it is an area that we're interested in and something that we're looking at. The next bullet down here is, well, here we've sort of titled, the title is still up in the air, but the power and performance data sheet idea, where basically having a standardized piece of literature information where all the manufacturers are reporting the same things, they're doing it in a standardized way, using standardized test procedures for all the information that's contained on that sheet, so that when customers go to purchase servers, they can take some of these data sheets and directly compare what the capabilities and power use of those servers. So here, a couple points there. We kind of say it's a little analogous to the DOE labels on refrigerators. I think there were some references to that before that sort of say this is how much power this refrigerator will use in a given year. May include things, configuration, different benchmark scores, power consumption, mentioned idle power and maximum power might be in there based on the spec power results. Power management features, anything that's in there that's set up already to save power using different power management techniques, and virtualization capability. So this, again, another thing that's kind of up in the air, but we've heard from a lot of manufacturers that this could be a useful thing, and in order for them to be able to sort of promote the features of their products. This sheet would probably be available in a standardized format, probably on the manufacturer's websites. When you go to look at the specifications, you would have maybe an Energystar link that would allow you to pull up this sheet and see all the different information there. And then also, we're thinking about having them print these actual data sheets and include them in with the server itself, so that when you pull it out of the box, you have this reference of what you can expect from the server. What?
It's too late. At that point, they've already made the purchase decision. There's another piece of paper that's going to get thrown in the trash.
That's a good comment. I think one of the ideas is just to have the information out there, so maybe for future purchases, they can look at this.
On the data sheet, that makes sense.
On the data sheet?
Yeah.
If you require people to ship paper, it's just trash.
Okay.
Yeah, they're not like refrigerators that sit in stores with a sticker you can see.
And you're killing all the trees too, but.
Most my data sheets are electronic.
And they're pulling the carbon out of the air, so we gotta keep the trees. This is an example that this was actually put together by one of our stakeholders who we ran this idea behind, and they liked it kind of, so they're a proponent of this idea, and this is really based on that DOE label that we were talking about, and there was talk about this earlier about having sort of, here's an estimated kilowatt hour number for the year. Here on the top you have configuration information, you have the spec power rating, the maximum power at the maximum spec power, which is the benchmark that we're looking at. So it's not to say that this is what it's going to look like. This is what one manufacturer has gotten back to us with their vision of what this might be. Okay, so access to power use, temperature, and processor utilization data. So that's the idea of having this information available to data center operators, having it available to maybe different external power management schemes you have, where you can actually monitor these servers in place. Hopefully the idea would be that you just plug the server into the system and you have instant access to all this information. So we're talking to manufacturers about that, about the capabilities that are in their machines currently, what's coming down the line, and are hearing that in many cases this is there, in many cases it is coming down the line. So it's something that we'd like to see so that people have improved management of these systems. One of the organizations we're working with right now and talking to is DMTF, that creates these kind of standards. Another group that I saw on the list that SNIA wants to get involved with, or is currently involved with. Yeah.
The DMTF, the SNIA management is based on the sim model.
Okay, great. So, and then the last one that I have in here is power management and virtualization. These are two things we're initially very interested in and still are very interested in. I think there are going to be a couple struggles with them. One of them being that a lot of power management features and virtualization is done at the software level. And what we're hearing now is a lot of servers are shipped without any OS capability or any software installed, which makes it difficult for us to create criteria around these two things.
Let those more be along the line of operational best practices rather than ratings on a server.
Well, they'd be more the capability to do certain things.
I mean,
Right.
it's got more to do with how you use it than with
In terms of
rating for buying.
in terms of say that again?
Well, if you run virtualization and increase the utilization of all your servers so that they're all running at 80% utilization except the last one, but that's an operational thing. That's not something you put on a spec sheet and you buy. That's the guy running the data center that's keeping his servers fully utilized.
Right. Yeah. I mean, it's a tricky issue
And
because
you shut off the ones you don't use.
Right. Well, that's what I'm saying is one of the challenges here is that it's not like a hardware requirement. Right.
It's an
So-
operational best practice.
Right, but there are. I mean, what we're looking into is are there hooks that the manufacturers can put in to increase maybe the likelihood that these would be used, or having them pre-installed, or in terms of virtualization, there's actual hardware modules, right, that make it so you can run virtualization without having to install the software. Now,
There are some hardware hooks and assists that make
Right.
it easier to write software effectively to make this happen.
well, those are the kind of things we're talking about, and this is still, the first bullet here says we're doing continued research into this because our knowledge obviously has some gaps.
There's also some hardware. There's also some hardware preloads you can do of virtualization with the servers as they
Well,
should.
there's
That
embedded,
technology
yeah.
exists today.
There's embedded.
Right, that's what I think
There's
I was
embedded
referring to,
hardware.
embedded software.
That stuff exists today. embedded.
Yeah, I mean, most of that stuff is a done deal. I mean, it's really around operational practices.
Right,
So if I buy a super energy efficient house and leave the windows open,
Right.
what the heck's the point?
Right, and that gets back to that's one of the differences between, say, the power supply requirement, right? The reason we're big on that is because that's guaranteed savings.
Well, that's a piece of hardware.
Right.
So the question then is, are you guys going to get into doing some operational best practices along these lines, or are you just focused on things that you can measure at the delivery of hardware?
I think where we're positioned, what we want to look at is giving incentives for these type of things. I mean, if there is anything that can be included in that box that's going to help bring about the operational changes, that's going to make it easier to run power management, that's going to make it easier to virtualize, that would distinguish that box for someone that wants to run those kind of systems, right? Then we're just trying to bring that.
I think the market has driven that. I mean, the the only thing I see that you have any real traction is maybe some kind of incentive program like PG&E is doing to get people to migrate and do a hardware.
Right. Yeah, I mean, that's a different issue. I mean, we're on the product category, you know, we're just looking at how can we specify that this box is going to be more efficient and has the potential for energy savings over
And remember, this is Energystar for servers, so this is part of the product labeling part of the program. There's also the Energystar Buildings program that's developing a facility level metric that initially is just looking at infrastructure systems, but ultimately we hope will be an end-to-end
The point is
metric.
no matter how good the server potentially is at energy savings, if you don't use it appropriately,
Right.
you ain't get, if I leave the windows open,
Correct.
the Energystar house is worthless.
Right.
But
So it's
let me just cut to the chase on this. If someone decides to use their Energystar equipment that way, it's their own business, as far as I'm concerned. I mean, my
Well, they
primary
may not know
business
they're
is to
leaving
try
the
to create
windows open.
demand for Energystar, get the market to change. But you're right, we wouldn't get the energy savings or OP nationally. So the way I would think about those criteria is that there's something in there for everybody. There are some people who think that power management is the best and the only thing we should be focused on because they want to draw our attention away from other things. And another way you can look at some of those criteria is that they do encourage the proliferation of other efficiency attributes. So,
You know, I think the other way to look at this is, this is a version 1.0 spec, and Energystar's been working with, with PCs. They've been working for over 15 years with the IT industry, and it's gone, you're on the 5th version of the.
yeah.
So it's a long-term relationship. These are the very simplest, easiest things to do initially, but the idea is to be engaged with this market for the long term and develop metrics and specifications that over time have a higher and higher probability of getting good energy performance. So for instance, well, I think it's your next slide actually, is getting at this end-to-end metric of computing output for power input or energy input over a given workload, so that you're trying to capture more of the
I
energy
understand where you guys are going,
performance.
but I would maintain that at any given day, a well-managed, non-Energystar data center will do much better than a poorly managed Energystar one.
Yeah, Larry,
There's
but
a
the
lot-
same argument.
There's a lot to that. And I think-
Larry, you could take an energy efficient car and put your foot on the gas and not have the tires inflated or things like that. You can't blame the standard for the way that it's going to be used.
I live with that example. I've got my son, my wife, and myself. The differences that you get on the instantaneous mileage is amazing.
Yeah. Right. So both to get to really good energy performance, you need both. You need the good hardware, the good design, and it needs to be
And
operated
best
well.
practices, yeah,
And there's
exactly.
really two different policies or program strategies that are needed to address both.
You guys aren't going to look at the operational side of this at all. You're just basically looking at
Energystar Buildings is, which is another part of the Energystar program. This conversation here is just about the product specification. So insofar as you need efficient products in the building, and then the building needs to be designed and operated well. Together, the two parts, the buildings and the product side will address both.
It's more than operating the building well, it's managing the servers and the workloads.
Well, when I say building,
Where the data goes into storage, right, and how much you move to nearline and offline.
when I say building, I mean system. The data, if you look at the data center as a system that includes servers and storage and networking and power and cooling, so that combined system, it's, ultimately you want some sort of end-to-end metric of the whole system, and then you also want metrics for the various components, the products that are going into that system.
Right. I describe Energystar as a non-panacea. It is not going to solve all of your energy problems or even significantly improve them unless you do some of the other things that are potentially as crucial or maybe even more crucial in terms of really managing the system, as Rich mentioned. which are critically important. But the products that we know are efficient, no matter how you use them, make it, make that data center operator's job just that much easier because they know they have efficient equipment. Now they have to use that properly or use them to their best capabilities. So there probably are. I think it's a positive contributor if used properly, but not a panacea. Granted.
So, Andrew, did you want to do the tier 2 stuff?
No, go ahead.
Okay.
Go ahead. How we doing? I think we probably need to move along as far as time goes, though. So try to
All
make
right,
it pretty
so I'll
quickly.
just touch on this fairly quickly because this is far off in the future. But basically, so the tier 2, as we were talking about, mentioned, I think in terms of what was going on with the computer specification, we're looking at sort of simplified power metric and then moving on to energy. Similar here, where tier 1 is going to be a fairly simple specification comparatively with power supplies and maybe some of these other requirements we talked about. And then tier 2 will really, that's when we'll really start to look into active power measurement. So again, we're looking at the Spec Power Committee, which I brought up earlier, where they started working on this workload in January of 2006, and that came out in December of 2007. So that right now is only one workload, so it's only the criticisms we hear, it's only specific to certain kinds of servers that are running certain kinds of software. They're looking at creating a number of different workloads in the coming year or so, and beyond that probably, to make a sort of suite of workloads that hopefully will describe the majority of servers in the market. Do you have a question?
Are all those workloads going to be determined by a single computer disk connected to that server?
In terms of...
Yeah.
One SAS drive, that's it, right?
Okay.
No, I don't think...
You don't know, and I'm asking you.
No, I mean, you can run the test on any kind of system you want, right?
They're not disk specific. I think the tests are designed to run without disk access.
Or just scratch
Well,
this.
the current one is definitely doesn't have disk access, right? Which is why they need more workloads.
Yeah, that's sort of akin to saying it's a great car, but once you put the wheels on it, and, yeah, I mean...
No, we're just testing the engine on the stand. We don't have the wheels on.
That's a fair enough.
It may allow things to be gamed where you have a server that only has one connection to a disk scoring out a better...
Well, so this has been one of the complaints that I've heard, is that they're just testing the energy efficiency of the CPU platform kind of thing, right? I mean,
it's the first start maybe, but not a full picture.
Right. And I think one of the things that I've told people, and they've raised this point, I guess always funnily sort of casting aspersions on their competitors in sort of a funny way. My competitors will find loopholes and they'll exploit them. Oh, yeah. So we've heard that, and we get a good chuckle out of it. People may or may not do it, which is why we've said, really, if you want to get to a tier 2, which we all sort of, without, everything always looks better sort of behind the curtain. You don't really know what tier 2 is, but we sort of all think it's got to be better than the stuff we have in tier 1. Well, I've said tier 1 will go away if we can come up with a tier 2. But the industry logically needs some time to figure it out. Many of you have maybe only gotten focused on this in the last, 12 months, 6 months, 3 months. So you need time to figure out to a tier 2. But right now, your customers say, at least they say to me, there's no downside for you to try to do Energystar right now. We would like to see it. We think it would help us. Again, they're the customers. They get to ask for what they want. So I've been willing to sort of make tier 1 with all of its warts, have a fixed period of time where it would apply and it would go away to be replaced by something that is more holistic, maybe more robust, maybe is more system oriented, even though that's probably going to be a little bit hard to do. And so we might work on parallel tracks, do a tier 1 and on maybe some of your committees could work on a tier 2 and take a year to try to figure it out.
Well, you won't find the competitive